Sagittarius A is not what you were told it was. For decades, every textbook, every documentary, every late-night space video has called it a supermassive black hole, sitting quietly at the heart of our galaxy. That description is wrong, or at least it's so incomplete that it might as well be a lie. Because the thing at the center of the Milky Way is not behaving the way a black hole is supposed to behave. It is doing something else, something stranger. And one of the most uncomfortable parts of the recent data is the direction it appears to be pointing. Straight at us. Sagittarius A is the radio source at the gravitational center of the Milky Way galaxy. It has the mass of about 4.3 million suns, packed into a space smaller than the orbit of Mercury. If you could somehow stretch a tape measure across the event horizon, the boundary past which nothing escapes, you'd get about 16 million miles. That's wider than the distance from Earth to Mercury at closest approach. All of it crammed into a single object with no surface and no exit. Every star in our galaxy, including ours, is in some sense circling it, the way water circles a drain. Our solar system makes one full lap around it, roughly every 230 million years. The last time we were where we are right now, dinosaurs hadn't invented themselves yet. So far, so normal. That's exactly what a supermassive black hole at the center of a galaxy is supposed to look like. The problem is everything else. Real black holes, the kind we see at the center of other galaxies, are loud. They are violent. They tear apart entire stars and spit the leftovers across thousands of light years. The supermassive black hole at the center of the galaxy M87, the one that became the first black hole ever photographed, is shooting a jet of plasma out of its poles that stretches over 5,000 light years into space. That jet moves at nearly the speed of light, about 186,000 miles per second. It is one of the most powerful things in the observable universe. Sagittarius A, by comparison, is silent. It eats almost nothing. It glows about 100 million times dimmer than it should, based on its mass. Stars whip around it at over 15 million miles per hour and survive. Whole clouds of gas drift close enough to be swallowed, and they just keep drifting. For a monster that should be tearing the inner galaxy apart, Sagittarius A acts more like a sleeping animal than a hunter. Astronomers have been trying to explain that quiet for 30 years. The first crack in the textbook picture came in 2019. A team using the gravity instrument on the Very Large Telescope in Chile was tracking hot blobs of gas orbiting close to Sagittarius A. They expected those blobs to circle the way water circles a drain, in any direction the geometry happened to favor. Instead, every flare they tracked moved on the same plane, the same tilt, the same orientation. It was as if Sagittarius A wasn't a featureless point at all. It had an axis, a pole, a direction it was spinning around, and that direction wasn't random. That alone wouldn't be alarming. Black holes are allowed to spin. Einstein wrote the equations for spinning black holes back in the 1960s, work that was extended by Roy Kerr in a paper still used by every astrophysicist alive. The issue wasn't whether the spin existed. The issue was what that spin axis was pointing at. Pull back for a second. Picture the Milky Way the way you've seen it in every artist's illustration. A flat disc, like a vinyl record, with a glowing bulge in the middle. Our solar system sits about 2/3 of the way out from the center, embedded in that disk. If you were a Greek god looking down at the galaxy from above, you'd see the spiral arms turning slowly, all of them lying in the same flat plane. A supermassive black hole at the center of a galaxy like ours is supposed to be spinning in the same plane as that disk. Its rotational axis is supposed to point straight up out of the galactic record, perpendicular to everything. That's the natural geometry. That's how every other galaxy we've measured tends to behave. Sagittarius A doesn't do that. The axis the gravity team measured, and that other instruments have since confirmed, is tilted. Not by a few degrees, by a lot. The black hole at the center of our galaxy is rotating sideways relative to the disk it's supposed to be the heart of. Its spin pole is pointing out across the galactic plane, into the spiral arms. And the patch of sky that pole is currently aiming at contains, among other things, our sun. I want to be careful here, because the next sentence is the one that gets clipped out of context. The pole of Sagittarius A is not perfectly aimed at Earth. It's pointing in a direction that lies roughly within the same general region of the galactic disk that we occupy. That is not the same as a laser sight on the back of your head. But it's also not nothing, because of what could come out of that pole. I'll come back to that. First, you need to know why the spin matters at all. When a black hole spins, it doesn't just rotate the way a planet does. It drags space itself around with it. Einstein's equations call this frame dragging. And around something with the mass of 4.3 million suns, the dragging is so severe that it twists the surrounding magnetic fields into a funnel. That funnel acts like the barrel of a gun. Anything the black hole eats, if it eats anything significant, gets squeezed into that funnel and fired out of the poles at nearly the speed of light. That's what a relativistic jet is. That's how M87 puts out a beam of plasma that crosses 5,000 light-years. Sagittarius A, right now, is not firing a jet. The funnel is loaded, but the trigger isn't being pulled. The black hole is too quiet, too underfed, to produce anything more than the occasional faint flare we can barely detect. The question is whether that's a permanent condition, and the data says no. In 2020, a team using the Chandra X-ray Observatory looked at the gas streaming through the area around Sagittarius A. Then another team used the James Webb Space Telescope to look at the inner few light-years of the galactic core. What they found, and what's been confirmed by follow-up observations since, is that the region around our black hole is not stable. It's getting more crowded. Gas clouds are drifting inward. A stellar mass companion may be slowly spiraling toward the central monster. Sometime in the next 10,000 to 100,000 years, by the standards of human civilization, an eternity, by the standards of the universe, a blink, something is going to fall in. When that happens, the funnel is going to fire. A jet from Sagittarius A would be one of the most powerful events in the recent history of the Milky Way. It would not be a sustained beam, the way M87's jet has been running for millions of years. It would more likely be a violent, short burst, maybe a few decades long, maybe a few centuries, lighting up everything in front of it with hard radiation, X-rays and gamma rays. That's where the tilt matters. If the pole of Sagittarius A were pointing straight up out of the galactic disk, the way a well-behaved black hole's pole should, then any future jet would fire harmlessly above and below the galaxy into intergalactic space, where there's almost nothing in the way for thousands of light years. It would be a fireworks show for any aliens watching from another galaxy. It would barely affect anything inside our own. Because the pole is tilted, that's not the geometry we have. A future jet from Sagittarius A would not fire into empty space above the disk. it would fire across the disk, through it, into the part of the galaxy where stars actually live, including, depending on the exact angle, into the broad neighborhood that contains our Sun. Let me slow down on what broad neighborhood means, because it's easy to overhype this and easy to underplay it at the same time. A relativistic jet is not a perfectly straight pencil beam. It opens into a cone. The cone has a width of a few degrees on each side, and at the distance of Earth, 26,000 light-years away, a few degrees translates into a region thousands of light-years across. So nobody is suggesting that Sagittarius A is locked onto the third planet of our solar system. The reality is more disturbing than that. The cone, projected outward from the current spin axis, plausibly intersects the part of the Milky Way that we live in. It's nowhere near a likelihood on any short timescale. It's just a possibility that wasn't on the table when the textbook picture said the spin was nice and vertical. If the cone did intersect us, even briefly, the result would not be subtle. Picture a wall of high-energy radiation sweeping across the galaxy at the speed of light. Anything in its path with an atmosphere gets that atmosphere chemically rearranged. The ozone layer that protects every living thing on Earth from ultraviolet radiation would be torn apart by the gamma rays in a matter of weeks. Surface life that depends on the ozone, which is most surface life, would face a sterilizing dose of solar ultraviolet within months. Nitrogen in the atmosphere would oxidize and rain down as nitric acid, a slow burn poisoning the oceans from above. Photosynthesis would collapse. The base of the food chain would go with it. We have decent evidence that something like this has happened in Earth's past. There's a mass extinction event at the end of the Ordovician period, around 445 million years ago, that some researchers have linked to a nearby gamma-ray burst. Not from Sagittarius A, from a dying star somewhere within a few thousand light-years. The fingerprint matched, the biology fits. The hypothesis isn't proven, but the geometry tells us something undeniable. The universe is perfectly capable of pointing things at us that we cannot defend against. Now picture Sagittarius A with a loaded funnel and a tilted axis. There's another wrinkle. This one is newer, and it's the part that makes some astronomers genuinely uneasy. In 2024, follow-up observations with the Event Horizon Telescope, the same instrument that gave us the first photograph of Sagittarius A in 2022, found that the black hole is spinning faster than the previous estimates suggested. Not at the maximum speed Einstein's equations allow, but close. The faster a black hole spins, the more tightly wound the magnetic funnel gets. The more tightly wound the funnel, the narrower and more focused the jet becomes when it eventually fires. A slow-spinning black hole sprays its jet over a wide area. A fast-spinning one fires a tight, concentrated beam. So the picture has shifted in just the last few years, from a quiet, fuzzy giant pointed harmlessly upward to a fast-spinning, tilted, magnetically loaded engine pointed at a part of the galaxy that includes our Sun, with a fueling event that's plausibly on the way within geological time. Before I take you any further down that road, I have to be honest about timescales. None of this is something to lose sleep over tonight. The likely interval between major flares from Sagittarius A is somewhere in the range of tens of thousands to hundreds of thousands of years. Civilizations are not built on those timescales. Cultures are barely built on those timescales. By the time the next big jet fires, humanity might be unrecognizable, or extinct, or thriving across other star systems. Nobody knows. What I can tell you is that the casual confidence with which we used to describe the center of our galaxy is gone. The thing in the middle is not a sleeping giant. It is a fast-spinning, sideways-tilted engine with a barrel pointed across the only neighborhood we've ever lived in. It happens to be quiet right now because there's not much falling into it right now. That is the only reason it is quiet, which raises a question that's harder to dismiss the longer you sit with it. Is black hole even the right name for an object that behaves this differently from the ones we see in other galaxies? Some theorists have started using softer language. Compact object, central engine, galactic core. Not because Sagittarius A isn't a black hole in the strict mathematical sense. The equations all fit. The mass is there, the event horizon is there, the shadow we photographed is real. But the picture you carry in your head when you hear the words black hole probably involves a hungry monster tearing stars apart and screaming radiation. Sagittarius A is not doing that. It is something patient, loaded, aimed. Picture a loaded crossbow that nobody is touching. That's the engine at the center of our galaxy. And the science of the last 5 years keeps narrowing the question from what is this object to what is this object going to do and which way is it? For most of human history, the center of our galaxy has been an emotional object more than a physical one. The Milky Way's bright bulge in the summer sky was a river to the Greeks, a path to ancestors for several indigenous cultures, the backbone of night to others. People built stories around it because they didn't have telescopes. We do now. We have radio arrays the size of planets and orbiting observatories that can resolve the dust ring around a black hole 26,000 light-years away. And the more clearly those instruments see, the less the picture looks like the one in the stories. The soft glow at the center of the summer sky is a structure with a pole, with a spin, with a direction. A featureless point of mystery has become an oriented object. Which brings me back to the number I told you I was holding for the end. Earlier, I said Sagittarius A is spinning and that it's spinning fast. I didn't tell you how fast. The latest analyses suggest that one full rotation of the event horizon, the boundary of the black hole itself, takes less than half an hour, roughly the length of a sitcom. The most massive object within 26,000 light-years of you is turning faster than the second hand on a wall clock, twisting space and magnetic field lines into a barrel pointed across the galactic disk every 20-something minutes. That is the engine. That is the cadence. That is what's been doing it quietly the entire time humans have been looking up. The next time you're outside on a clear summer night and you find the constellation Sagittarius, look just to the right of the spout of the teapot shape. That's the direction. That's the heart of the galaxy. And somewhere behind all that dust and starlight, 4 million suns of compressed matter are turning. On a sideways axis, in a spin you could time with a kitchen timer. Patient. Quiet, loaded. We used to think it was just a black hole. It might be more accurate to call it a question we haven't finished asking. And one of the things we haven't finished asking is what happens to us on the long timescales the universe actually cares about, when the engine at the center of our galaxy finally finds something worth eating. Thanks for watching, and I'll see you in the next one.